Kubernetes is a very awesome technology. It's exciting to work with. It's just great. And in this video, we're going to work with Kubernetes. Specifically, I'm going to show you how to deploy an NGINX container on a Kubernetes cluster, but not just any Kubernetes cluster. It's a cluster that we will be creating in this very video. So let's go ahead and get started. For this particular video, off camera, I went ahead and set up 3 Linodes, one to act as the server, and then 2 others to act as nodes. For the master server, I recommend at least 4 GB of RAM. And for the individual worker nodes, they can have 1 GB of RAM apiece. That's totally fine. I also recommend that you take a moment to secure your Linodes as well. There's already documentation on Linode's platform that you can read and videos you can watch that detail the process of securing your server. And the topics include, but are not limited to, installing all available updates, securing SSH, and more. But just make sure that you've done your due diligence to secure your Linodes, and we'll get started. On my end, I've already gone ahead and used SSH to connect to each of the 3 servers. So on this tab, I have the master, and then I have the first node, and then the second node. I've already installed all of the updates on each of these 3 servers. And I've also set the host name as well, which is important because we want to make sure that we're able to differentiate which host is which. There's a video already on Linode's channel that goes over the process of setting your host name. So let's go ahead and get started. Now, the way that this tutorial is going to be laid out is that everything I tell you needs to be done on each of the 3 Linodes unless I tell you otherwise. The majority of the setup is going to be the same on each until we get near the end. And the first thing on our agenda is disabling swap, because Kubernetes actually requires swap be turned off. And, well, that's easy. We just run sudo swap off -a. And of course, since I'm logged in as root, I don't need sudo, but you get the idea. This command will actually turn off swap on the system. We can see that swap has 0 available space. And then we'll do the same on each of these as well. And we should be good to go. Now, first and foremost, you'll want to make sure that any previous installation of Docker or Kubernetes is removed. If you've just created your Linodes for the very first time, then this doesn't apply to you. But if you are recycling or reusing a Linode that you've previously created, you'll definitely want to make sure that you've removed any previous Docker or Kubernetes packages that you might have installed. For example, a command such as this would remove other components of Docker. I'll leave it up to you to remove any packages that aren't necessary. First of all, on each of the 3 servers, what we're going to do is install some packages. And some of these might already be installed. So we want to make sure that apt transport HTTPS, CA certificates, curl, and software properties common are all installed on each of the servers. And in my case, it looks like only one of those 4 was actually necessary. So what I'll do is just copy this command, and the results should be the same on each because they were all created with the same image. And there we go. So what we'll do first before we add the actual repository is add the GPG key for that repository. And to do that, we can use curl -f s uppercase S uppercase L, just like that. And then the URL. We're just using curl to grab the GPG key for the Docker repository. Then we're using the apt key add command to add it to the system. And now we can add the actual repository for Docker. So we're just using the add apt repository to add the Docker repository as you see here. And then this right here allows us to basically insert the release code name into the repository right there. So I'll press enter. It's already updating the repository index and it's done. If you have any problems or see any errors on your end, just check the sources list file to make sure that there's no typos. And to do that, we'll use cat etc apt sources.list. Take a look at the end of the file, and we could see that we have the download.docker.com repository right here. Everything seems to work just fine for me in my case, so we can go ahead and continue. But if you see any problems on your end, just make sure that everything was typed exactly as I typed it in the previous command. Now normally you would run sudo apt update, but that's not necessary for us because it automatically did that when we added the repository. So next what we can do is actually install Docker. So we'll run sudo apt install docker-ce, just like you see on the screen right now. And I just press enter to go ahead and accept the default of yes to install the package. And we can see that it's installed. And then we could check the status by running systemctl status and then docker. And we can see that it's running and it's also enabled as well. Next, we're going to repeat the same commands on the other two nodes. And what I'll do is just paste the first of the commands into node 1. And that was to add the key. Do that again here. Then I'll add the repository, and here as well. And then let's install the package. And now each of the 3 servers should have all of the changes that we've made so far. So I'll clear the screens on each. And then we'll continue to the next step. Now the next command is actually optional. I highly recommend that you create a user for yourself on your Linode so you're not actually using the root user. And off camera, I've already done that. I've created the user J on each of these 3 servers. On your end, you should consider adding whatever your username is for your local user account to the Docker group, so that way your user is able to manage Docker containers without the need of sudo. So for that, we'll use usermod-a, uppercase G, then the name of the group, which is Docker, and then the name of the user that we want to add to that group. And I'll just copy this command here and just run it on each of these servers. Now, if you were already logged in as that local user on your end, I recommend you log out and log in again. In the next step, we're going to run an actual Docker container. And if you haven't already added your user to that group, or you are not logged in as root as I am, you'll need to run sudo in front of this command. But otherwise, you could leave that out. What we're going to do is run docker run and then hello-world, just like that. I'll press enter, and it's going to download that image and run it. And then on each of the servers here, we should test this out. It worked on that one and this one. And we've already run it on this one, so I know that Docker is all set and ready to go. Now the next command is fairly long, so what I'm going to do is paste it in. And on your end, I highly recommend that you copy this command from the documentation page that matches this video, because by doing so, you'll be less likely to encounter a typo that makes the process fail for some reason. Now next, we need to create a new file on the system. And what this is going to do is configure Docker to use systemd as a cgroup driver instead of the default, which is normally cgroupfs. So you might need to use sudo if you are not logged in as root as I am. But basically, just type the name of your preferred text editor, and then the path to the file is going to be /etc, and then docker, then daemon, with an a.json, just like that. And I recommend that you copy the contents of this file from the documentation page that matches this video, because by doing so, you'll be less likely to encounter a typo. And I'll go ahead and paste that right here. And there we have the contents. So I'll save the file, Control O, and then Enter, and then Control X. And then on each of these three, we'll need to do the same thing. And there we go. And then next, what we're going to do is create a new directory. And this is actually going to be a systemd directory for Docker itself. And I'll just copy this here. All right, so we should have that new directory on each of our three servers at this point. And then next, systemctl, and then daemon reload. And then we'll also want to restart Docker as well. And to be safe, we should check the status. Make sure it's actually running. We didn't make any mistakes. That one's good. And that one's good. And that one's good as well. So next we have another GPG key that we'll need to install on each of the three servers. And this one is actually for the Kubernetes repository, because now we're going to get started on installing the packages that are required for Kubernetes. So we'll run curl -s and then the URL. So we'll just curl the key from this URL, and then we'll pipe that into sudo apt key add. So I'll press enter. So far so good. And as you probably have guessed, we need to run that on the other two as well. So next, on each of the three servers, we could add the repository that's necessary for Kubernetes. And I'll paste that command right here. So essentially, we're just echoing the repository line into a new file at /etc/apt/sources.list.d/kubernetes.list, as you see on the screen right now. This file didn't exist before, but will exist as soon as we run this command. And then we can run apt update to refresh the repository index. And that one's done. And now we have the repository on each of the three servers. Next, on all three of these servers, we're going to install the following packages. So apt install kubelet, kubeadm, and kubectl. Now next, what I'm going to do is hold the packages that we've just installed at their current versions to avoid any surprises, such as the packages for Kubernetes being updated before we're ready for them to be updated. And for that, we can run apt-mark, then hold kubelet, kubeadm, and kubectl. And we'll do the same thing here and here. Now the next command that we're going to run is going to set up the Kubernetes control plane, and this should be done specifically on the master, not the other two nodes. So this is the first command that is actually targeting one of the three servers instead of all of them. The control plane is a very important component of Kubernetes and is responsible for allocating resources to your cluster. It also manages the health of your cluster as well, and it even ensures that the minimum requirements are being met. So what I'm going to do now is switch to my local user. So we can go ahead and initialize our cluster with this command right here. This is going to set up the pod network, and we have to have a pod network in order to have a cluster. And this command should take care of that. And what this is going to do is basically initialize our entire cluster. So I'll press enter. So now our cluster is actually initialized. We have 3 commands right here that we should run as our local user. And what this will do is set up the configuration file to be used by our local user so our local user can interact with the cluster. So what I'm going to do is just copy each of these 3 commands here and paste them in. I'll grab the second. Then I'll grab the last one. And we should be good to go. So at this point, we can run kubectl, git, and then nodes. And we have our cluster right here, but it's telling us that it's not ready. And why isn't it ready? Well, in our previous command, we did initialize our cluster. And we used this command right here to do that. So basically, we set up our network, we chose a network CIDR for it, and we told kubeadm to initialize based on that, which it did, but it's not actually able to set up the cluster without a network policy driver, which we'll need to install next. Now, there's several different network policy drivers that we can use. It's beyond the scope of this video to go over all of them, but to keep it simple, what I'm going to do is show you how to initialize a network based on Calico. And there's 2 commands for this. I'll paste in the first right here. We'll run kubectl create and then -f, which expects a YAML file. The YAML file is located at this URL. So I'll press enter. And I know that went by very fast, but you could check out the documentation page for that specific command and you can copy and paste that into your terminal. And the same with the second command, which is going to be this one right here. It tells us that it was created. So if we run kubectl and then git nodes, we see that it's still not ready, but that's okay. Sometimes it takes some time after we initialize and then we set up the network policy driver. Another command that we can run to see what's exactly going on in the background is this one right here. I'll paste it in. We're going to git pods, and we want to use all namespaces because we want to see everything. So I'll press enter. You see that there's actually quite a few here. And they all say ready and running. And that's really all we need. So let's check the status again. We'll get nodes. And now our cluster is actually ready to go. Now earlier in the output, when we initialized the cluster, I'll scroll up a bit. We saw this join command right here, and you may need to scroll up quite a bit to find it. But basically what that is a command that we can use to join a node to the cluster. So if I go back to the end, again, kubectl, git, and then nodes. We don't have any, we only have master. Master is ready, but master by itself isn't really enough. So on node 1, I will paste in that join command. I just copied it from the output in the other tab. Again, you might have to scroll up a bit to find it. I'll press enter. And that one appears to be done. Let's see what happens. It says that it's not ready, but it did add it. That should be okay. Sometimes it takes a bit of time. And we'll paste that join command here on the second worker node as well. And apparently that one is finished. So back here on the master, let's get nodes again. And node 1 has become ready. So we know the process is working. So we just need to give node 2 some time to come up and be online as well. And now both worker nodes are ready. The master is ready. We should, by all intents and purposes, have a fully working cluster now. And we can test that by creating our first deployment. And a full walkthrough of setting up a deployment is beyond the scope of this particular video. But what I'm going to do right now is show you how to deploy NGINX to our cluster, which will show that it's working. And then from there, you can look at other things that you can deploy and put your cluster to use. So first of all, let's run kubectl and then git deployments. We don't have any currently, and that makes sense because we have yet to create one. And we can create one right now with the command that I'm about to show you, which is going to be kubectl, and we're going to create a deployment. And we will call the deployment NGINX. And then -- image, we need to tell it what image we want to use for the deployment. And we'll set that equal to NGINX. Press enter. And it tells me that it was created, so if I get deployments again, it shows that we have the deployment right here. It's not yet ready. Again, it takes some time. It's only been up for 5 seconds according to the output. So we'll give it a moment, and then we'll check it again. And now we see that it's running. To get more information about our deployment, we can run kubectl, then describe. Describe gives us more details about something. And then what we want to get more details on is a deployment. And the deployment that we want to get more information on in particular is NGINX. We get a bunch of information here, as you can see. And now what we can do is make the NGINX deployment accessible from the internet. By default, Kubernetes does not like to make things available publicly, and that's great because we don't want things to be publicly available unless they need to be publicly available. In this particular case, let's assume that this NGINX container is actually something that's extremely important to our organization, and we want other people to be able to access it. So what we can do is run kubectl. We can create a service. And the particular type of service that we want to create is called a node port service. So we will type node port right here, call it NGINX -- TCP, set it equal to 80:80. I'll press enter. It tells us that the service was created. So kubectl git and then service. And we can see the NGINX node port service there on the last line. Now here we see a port of 31,672. So let's see if it's working. So what I'm going to do here is paste in the actual public IP of the master and the colon. Let's grab that port. We'll paste that right here and let's see if it works. And it says, welcome to NGINX. As you can see right here, we have created an NGINX deployment on our Kubernetes cluster, and we've also made it publicly accessible as well. What's also pretty interesting, if we grab an IP address of any of the other nodes, for example, I will grab the IP address of node 2, and I will replace the IP address right here with that one instead, and press enter, we can see that it still works. Now the first time, we used the IP address of the master server, and the second time, one of the nodes. And it doesn't matter what IP address we use with node port. Any IP address in the cluster should know how to actually transfer you to the appropriate resource that's actually running the container that you're trying to connect to. That port number is actually opened cluster-wide, not on a particular host. That's why I'm able to add any of the IP addresses here with that port, and then it allows me to access the container. Of course, there's other types of services and deployments that you can set up, but I'll leave it up to you to look around and see what kinds of awesome things you can run on your new cluster, because now that you have a working cluster, the sky's the limit. So go ahead and have some fun. So I hope this video was as much fun for you guys as it was for me making it. I love working with Kubernetes. And in this video, we created our very own cluster and we deployed an NGINX container to our cluster. It was great. So click that subscribe button if you haven't already done so. We have some fantastic videos coming very soon, and I'll see you next time. Thanks for watching.